Sleep physiology. Sleep is a biological state in humans, where typical changes occur in brain electrical activity during sleep and the increase in the proportion of slow waves as sleep deepens.
Sleep phases. Vigil. Before beginning the dream, the subject is awake, relaxed and with closed eyes. In the electroencephalogram, an alpha activity interspersed with beta activity is recorded. The movements of the eyes are present and the muscle tone is high.
Sleep of slow waves, also known as non-REM sleep, non-rapid eye movement, is the deep sleep, in which it is difficult to awaken the person, and if it is done, it appears bradypsychic, confused and disoriented. In this state of sleep it is observed, absence of rapid eye movements, progressive decrease in body movements, muscular quiescence, decreased muscle tone in extremities, predominance of the parasympathetic system, regularity and slowness of the pulse and breathing, with reduction of blood pressure, decrease in temperature, lower warning threshold than that of REM sleep. In non-REM sleep there are also daydreams, which are described in the form of pleasant or unpleasant sensations.
It is constituted by the phases. Stage 1 non-REM coincides with the onset of sleepiness. Alpha activity decreases, is interspersed with a desynchronized activity composed of beta and theta waves. The subject progresses gradually towards a deeper dream. Stage 2 non-REM. It is a light sleep phase. The bass activity is theta, on which the K complexes appear intermittently. Stage 3 non-REM. Medium sleep. Delta rhythm predominates. Stage 4 non-REM. It is the phase of deep sleep. It is monomorphic. Only high-amplitude delta waves exist.
REM, rapid eye movement. This state has been called paradoxical because quick eye movements are observed, and of the small facial muscles submittal. Increased cerebral blood flow is recorded. Changes in the autonomic nervous system, in oxygen consumption, in body temperature. Rise and irregularity in pulse is characteristic. Rise and irregularity breathing and blood pressure. Maximum muscle relaxation is observed. The maximum warning threshold. In men, penile erections are related to episodes of REM sleep, with a light sleep according to E criteria with a brain activity similar to active wakefulness. It is the dream period in which the most cinematographic reveries appear, although sometimes it is not possible to remember their content. And if the subject is awakened in this stage, it will soon recover the alert state.
Our memory and the dream. What do we know about our memory in relation to the dream? Sleep actively supports the formation of long-lasting memory representations. Has also been shown to promote neocortical synaptic plasticity. The formation of long-term memory relies on the two distinct processes of encoding or learning and consolidation. Retrieval is a third process that contributes to memory formation by reinstating the stored information. Between encoding, that is the uptake of the information, and retrieval lies the period of retention. During this retention period, memories are not merely passively stored but that an active process of consolidation occurs. That memory is consolidated during the brain's offline periods of deep slow-wave sleep.
In the neocortex, it is the name given to the most evolved areas of the cerebral cortex. The formation of dendritic spines have been observed during sleep after learning a motor task, as a neural substrate of memory formation, which was positively related to task performance.
Schematic of the classical functions of sleep for memory. In the hippocampus-dependent declarative memory domain, during wakefulness, information, yellow arrows, flows through the sensory cortices to the fast-learning system of the hippocampus, green arrows, which quickly binds the information into a transient representation. During subsequent sleep, specifically non-REM and slow-wave sleep SWS, the memory trace is replayed repeatedly, red arrow, which leads to its transformation and integration into the long-lasting stores of the neocortex, that is active systems consolidation, blue arrows. Next to active systems consolidation of relevant memory traces, sleep also renormalizes synapses leading to the erasure of irrelevant information. While the synaptic homeostasis hypothesis underlines the importance of SWS for renormalization in the cortex, evidence suggests that in the hippocampus rapid eye movement REM, sleep plays a major role. During subsequent wakefulness, the consolidated information can be retrieved without recruiting the hippocampus, green upward arrows, and new information can be encoded into its replenished stores, yellow and green downward arrows.